In the following video, we're going to do an example on how to solve a system of equations by using inverse matrices. And so in this problem, we have the system 4x minus 7y equals 2 and 3x plus 5y equals 9. And so the first thing I want to do is I want to set up this system as a matrix equation. And so we start with our coefficient matrix. We have 4, -7, 3, 5. Those are our coefficients. And we want to take the coefficient matrix and multiply it by our variable matrix, which is x and y set up as a column. And that should be equal to our solution matrix, which is 2, 9, set up as a column. And so now we have our matrix equation. And remember, in order to solve, this is your coefficient matrix, the 4, -7, 3, 5, we need to multiply both sides by the inverse of this matrix. And so what I'm going to do here is I am going to find the inverse. And so to find the inverse, what we do is we do 1 over our determinant times the matrix, where D and A switch positions. You change the sign of B and you change the sign of C. And so my determinant, if I'll take care of that here, DET, 4 times 5 is 20, minus 3 times -7, which is -21. So 20 minus -21 is 20 plus 21, which is 41. So then I have 1 over 41 times the matrix. A and D switch places. So 5 is now here, 4 is now here. You change the sign of B, so -7 becomes +7. And you change the sign of C, so 3 becomes -3. And then we do our scalar multiplication. So 1 over 41 times 5 is 5 over 41, times 1 over 41 times 7 is 7 over 41. 1 times -3, so you have -3 over 41, and 4 times 1 gives you 4 over 41. And so this is my inverse matrix. And so remember, you multiply the left side by the inverse matrix. If you multiply a matrix by its inverse, they cancel out. It gives you the identity matrix. And so what we're going to focus on is we're going to be focusing on doing the right side of the equation. So I have my x, y matrix. It's equal to, and remember with your inverse, you do front multiplication. And so we have our 5 over 41, our 7 over 41, our -3 over 41, and our 4 over 41. And we want to multiply it by solution matrix 2, 9. Front multiplication with the inverse. And now perform the math, perform the multiplying. So 5 over 41 times 2, 5 times 2 is 10, so you have 10 over 41, plus 7 times 9 is 63, so plus 63 over 41. On the bottom, you have -3 times 2, you get -6 over 41, plus 4 times 9, which is 36 over 41. And then we just perform the addition. 10 plus 63 is 73. And so we get 73 over 41. And -6 plus 36 is 30. So you get 30 over 41. And so x is 73 over 41. Y is 30 over 41. And our final answer is to be written as an ordered pair. So the coordinate of intersection of this system is 73, 41, comma, 30, 41. And so that is how we solve a system of equations by using inverse matrices. Set up your coefficient matrix, your variable matrix, and your solution matrix. And this represents your matrix equation. Find the inverse of the coefficient matrix. Do front multiplication with that inverse with the solution matrix. Perform the multiplication and you get your answer.